school for like 4 years and to be back. Okay, it was like 4 or 6 years. She said,
I thought it was like
8 years. That's how it is. She got down to her last year and they found out they were having 12s. And all of a sudden, they were testing the 12s was actually ready. So they had to put down money. They had to put in the last year.
So I'm really glad I did not attend either.
And she was like, my sister just couldn't do it. You know, Miss Whitley tried to do that. Oh, see, like, that's just not wrong.
I just want to go. I have gym break period. I'm not wasting minutes on.
I wish I was. It was so boring as always. And she was
Jen, that's not about what I do.
like, we're just trying to make you say something like that. I don't care. I literally think they talk about business. I know why I do that. I cannot do that.
Well,
That's all.
I'm like, most of the time when not put those on the gas chamber, they're okay. Couldn't do it. She spent 8 years. I'm like, how do you spend 8 years and just not learn to start with 9? It's not like they put me down like a cool way. They literally just honestly.
Was that short? And it was not. I was like, you were just not.
We saw in the backyard, because anything in our backyard is always good.
Yeah.
So, and I was like, we were like, hey, what's that in the backyard? And Mom was like, oh, no, go check it out. I'm like, yeah, go check it out. It was impossible. But then we got hit and the spray was going on. So, and I was in the front room and my friends like, those things, honestly, they're kind of creepy. They're sharp. But he says that he hates the cat. That's okay. But we have a cat, we don't need
guys, let's have a good day.
That's what my dad thought. It's like,
Yeah.
oh, thank you.
They have AP stats.
Thank you.
Since I can't paint the bricks, paint this.
Okay.
Okay. Put your name on the back. Okay. You might get to join the ranks, a very exclusive club of only one other person. Got the pink too.
Oh, really?
Ariana. There are a few others that are trying to join that club. I don't know if they will or not. I have 3 other students right now in calculus that had an AP stats. Caleb Burr, Dawson Cochran, and John Hada. I saw your email. Did you get mine back?
What email? Oh, yeah.
Okay.
I was so confused. I was like, Kelly, what's wrong with it?
Nothing's wrong with Mr. Kaufman. Nothing was wrong with Mr. Kaufman. It was not Mr. Kaufman that was not well. I did feel bad for Mr. Saka. She had a very rough case of food poisoning. And then our puppy was not very kind yesterday. Oh, long time no see.
Maddie Miller to the front office, please. Maddie Miller.
Are you leaving?
No, I wanted to Miss Johnson about scholarship for my
You
stuff.
left your water bottle. You left your water bottle.
Well, I'm back. I'm not leaving.
Why are you taking your book bag?
Because I'm going to see Miss Johnson about scholarship stuff, and my stuff's in the book bag.
Okay. I have an answer about this. Or is very similar to another problem that we've done in the past. Yeah. That it is it's a repeat from our first quiz. My advice to you is to set up a mean value theorem question. That's the reason why I recycled it, is because it was a very missed question on the first quiz. So I recycled it for this. I encourage you to go back and look at the mean value theorems. Okay, and how we can do those right.
Can I plug this and then re-plug it back in real quick? We can mess something up.
Yeah. If it messes anything up, I'll deal with it. Let's see. Now Maddie is. We are only missing Cal. Let's see if Cal shows up in a minute. Guys and gals, let's get started with this. These two warm-up problems, please. We have some homework for me to check. At least we should have some homework for me to check. If we have any quiz questions, we'll go ahead and we'll deal with those as well. Any issues with our quiz today, we'll talk about here as well. As I gather all my belongings to go take my spot. Those of us joining on live stream, feel free to also ask quiz questions or homework questions if we need. I do want everybody to be working on these first two warm-up problems. I'd like us all to be working on these two warm-up problems, please. if I'm not incorrect here, I should be looking for our 3.5 homework from you guys and our 3.6 homework from you guys, and from some of you, a few more than that. So let's go ahead, let's get things organized, let's get things squared away here. Here. Okay. It's good. Lots of work, and that's what you should see here for 3.6. Okay.
I would like a little bit more here, more than just the rigor. I should see the few tests ran out. Same thing for me. I want to see that full test worked out. Okay, how do you know that? How do you know that? Okay. If you do that for our quiz, I'm not going to give us full credit. Yeah, that's everything on the road. So it's going to be 2. Notes. Good. Okay. 4. Even if it feels like it's clear, you've never seen it. You'll be surprised that once in a while they sneak up on you. A little bit more guidance. Okay? You just have an answer, there's no work there. About it. Okay? Yep, that's about right for one. Okay? Yep. You see why I wanted to do that lesson in person, but honestly, I couldn't.
After I show you this, I run this to the library.
Okay.
That's 3.2. Anyway.
That's not a question. It's not a question. I understand the science. Do a little bit.
I did two of those stuff and stuff. And that was fine.
I think it's just at the end of the day. Then,
Where's the word? With the first word, because you said with the word with the test, where she put numbers. With the max and mix. There's a word for sure that goes with max and mix. I hope we're not trying to do that for our quiz. Round and cut. Way too much work to be shown for those types of problems. I'm not trying to be a jerk, nothing, but way too much work to be shown. That's the first grade test, all the way through, the second grade test, all the way through. When I do those on the board, I would have been here to do that lesson, I would have filled that board probably twice over doing one problem. Okay? All right. Let's go ahead. Let's get this show
on the road here. So if we have any quiz questions or anything we'd like to talk about, we can go ahead and do so. Do we have any quiz problems we would like to talk about, as our quiz is due today, right? Midnight? Correct? Any problems with our quiz we want to talk about, we'd like to go discuss? I'm not going to do them for you, of course, but I will at least take a peek, try to make sure that you're on the right track. I know Abby and I talked about number 4 earlier. I gave her the piece of advice. That is a mean value theorem question, an MVT type problem. You need to go back and look at those. So any of them that we want to talk about or go through. Out of those 4 questions, when I completed my answer key today, I came up with 38 individual points that I'll be looking for. 38 individual points. Now, I will tell you, you can use Desmos to double check your answers to make sure you're right, but if you don't have sufficient level of work, I'm not going to be giving it credit. Okay, I don't see any questions there in chat about it. You all don't have any questions here about it. Do we have any questions we'd like to talk about? 3.5 or 3.6? 3.5 or 3.6 homeworks? We're all set there too. Okay then. Let's go ahead and let's start with our first slide here. Our slide with our warm-up problems. Our slide with our 2 warm-up problems. Who would like to help us out with one of these 2? These are AP Calc released exam questions from a while ago, but still. That's why they look like this. That's why they read like this. Who would like to help us out with one of them? Do the second one? Okay. So Bianca's going to help us out with the second one here. Given the function is defined by this equation, 3x to the 5th minus 20x. My mouse is over that, but I believe it's another exponent there. Let's move it real quick just to make sure we get the correct one. Yep, 20x to the 3rd. Find all the x values for which the graph will be concave up. So this is a pretty standard second derivative test question, yes? Okay, so let's go ahead. Let's begin my second derivative test. Let me go ahead and erase off some of this stuff up here already. So Bianca, go ahead. Tell me what we're going to do here.
So first, I found the first derivative.
Okay. Which is what?
15x to the 4th minus 60x squared.
15x to the 4th minus 60x squared. Okay, and then the next thing we're going to do?
Second derivative.
Second derivative, which is?
60x to the 3rd minus 120x.
Awesome. Now, what are we going to do with this?
Find the critical values.
We're going to find the critical value. Well, not really the critical values. Critical values are with the first derivative, but same idea that we apply. We want to find zeros and does not exist, right? Is there any point where this does not exist? No, this is a continuous function. It's continuous everywhere. So we're going to be focusing more on where the second derivative is going to be equal to 0. So 0, 60x to the 3rd minus 120x. How did you approach this?
Well, first I took out a 60x.
I think that makes a really good idea. 60x, what does that leave behind? Of course, x squared and minus 2. Okay. And that's not going to factor for us, but we can go ahead and set each equal to 0 because that's a pretty quick solve. So 60x equal to 0, that of course gives us 0. And x squared minus 2 equals 0, that's going to give us plus minus root 2, correct? Are we all okay and we're all comfortable with what we've done so far? And those of us in chat, make sure that you let me know. We can make sure we see everything. I'm writing a little bit smaller, so if I need to write bigger, let me know. Okay, so we need to test these values. So let's make a number line. In the middle, of course, we'll have 0. We'll have positive root 2. That doesn't look like a 2 at all. Come on, Mr. Coffin. And a negative root 2. What numbers did you pick, Bianca?
-2, -1, +1, +2.
-2, -1, +1, +2. I think that those are great choices here for this. We do need to test all 4. So let's go into our third derivative, or second derivative, excuse me, third derivative. 60x cubed minus 120x. Okay, so when we put in a -2, what are we going to be looking at here?
You get 60 times -8 and then 120 times -2. Which ends up being -480 plus 240.
So we are negative. Okay, when we put in -1 in, what are we looking at?
+60.
We should be looking at positive 60, so a plus there, yes, okay. What about between 0 and root 2, a positive 1?
And not -60.
We should be looking at negative again, and then above 2, above root 2, we're going to go back to positive. Very good. So this is what our number line looks like here as we test these values. Nobody in chat commented either way whether or not they can see okay. So I'm going to assume that they're fine since they don't want to participate. So let's answer the question. The values for which we are concave up. The values for which we are concave up, or the intervals will be concave up, are going to be what? That's going to be between negative root 2 and 0, yes? And root 2 through infinite, correct? So we are looking at here, looks like B is our answer, correct? Instead of interval notation, or excuse me, yeah, instead of interval notation, we went back to what's called set builder notation. That's where we use the inequality signs instead. Questions here for the second warm-up problem. Pretty straightforward, second derivative test kind of question. There are some other things that we can do with the second derivative test, but for it, we need to get a little bit more information. Those things require us to run the first derivative test, like finding max and min. Okay, who would like to help us out with the first one? Who would like to help us out with the first one? What is the first one asking us to do? Let's start with what type of question is our first warm-up problem. What is it asking us about right now? Somebody other than Bianca, please. There's 4 other ones of you in here, and you all know how to read. What is the question at hand here? What do I want to know? Points of inflection. Where do we find points of inflection at? Is that a first derivative test or is it a second derivative test? Is it Rolle's theorem? Is it mean value theorem? Or is it limits as we go to infinity? Those are the things we've talked about. So what is it? Where do we find points of inflection at? It's a second derivative test. Thank you, Evan. So let's go ahead. Let's start setting up the second derivative here. Of course, we'll have to start with the first derivative. X squared cosine x, yes? Cosine of, excuse me, x squared. So let's go ahead. let's jump into this here. So with our first derivative, we're going to be looking at a product rule here, f and g. The derivative of f is, of course, going to be 2x. Derivative of g here is actually a chain rule. Derivative of g here is actually going to be a chain rule. It's going to be 2 cosine x. And then the derivative of the cosine, of course, is going to be negative sine. Oh, I did that backwards. I did that backwards. Negative sine x squared, and then the derivative of what's inside, which would be 2x. So we're looking at g as negative 2x sine x squared. So let's go ahead, let's set up our first derivative here. G times f derivative, so that's cosine of x squared times 2x. Plus our f, which is x squared, times our second derivative, our g derivative, negative 2x sine x squared. Let's go ahead, let's do a little reducing here. 2x cosine x squared minus 2x to the third sine x squared. Jake, question.
It gave you the first derivative.
It did give me the first derivative. Mr. Coffin did not read clearly, but that's okay. Doesn't mean that we can't use this. It just means that we skipped a whole nother step here, right? That this is actually, we'll just adjust here. It's our second derivative. Questions here? Okay. Is there any point in time where this is not going to exist? Think about sine, think about cosine. Is there any point where those don't exist? Let's start with that. No, those are continuous functions, aren't they? They don't have asymptotes when you think about them. Tangent would be a concern. Tangent would be a problem. Secant, cosecant, cotangent would all be problems, but not sine and cosine. They're continuous functions. So we're okay with continuity. There's no point where this is not going to exist. So we're going to focus on, of course, the latter part here, which is, of course, the zeros. So where does this mess equal 0? So how would you like to get started with this wonderful thing here? I think it would make sense to factor. If we can factor anything down, let's do so. I do see that both groups have a 2x, so let's take that out. So 2x, that's going to give us cosine of x squared minus, it's going to become x squared sine x squared, correct? Are we all set so far? We're all good so far? Yes? No? Okay, well, this gives us one critical answer right here. 2x equals 0, so x would be 0 right there. That's a point of interest to us. Why is that point specifically a point of interest to us? Because it's between my interval of -2 and +2, right? So this gives us at least one. Of course, we already knew that because 0 is not an option for this answer. But we have at least one. So now we have to focus on the latter part here. So what are we going to do with this secondary part? What are we going to do here? I suggest we take it, we set it equal to 0. Cosine of x squared minus x squared over sine x squared, all equal to 0. Okay? So, what should we do here? How do you want to solve this one down? There's a couple of different ways we can approach this. From here, it's just a really advanced trig problem, gang. From here, this just becomes a really advanced trig problem. Would it make it easier if we simplify this down a little bit? Let's try that. Let's try to simplify this down a little bit. What I'm going to do is I'm going to add this x squared sine x squared to the other side. So I'm going to get cosine x squared equal to x squared sine x squared. Now I'm going to go ahead, I'm going to divide everything by cosine x squared. The reason being, that gives me 1 equal to x squared, and I'm going to reduce this down to tangent x squared. Does that help this out a little bit more? Now that we're down a little bit more simplified. I might make us come back to this problem because I don't want to waste too much more time with the warm-up problem. We're already 20 minutes into class and we haven't actually started the lesson for today. So, do we have any further ideas about this one? I've tried to lead you all the way up to it. From this point, you got to kind of figure it out on your own. No, because we'll end up with square root of tangent. It'd be nice if that was tangent squared, but it's not. Okay, I'm going to leave this here, and we'll come back to it. All right, because I don't want to waste too much more time. We've already, like I said, we're already 20 minutes into class. Actually, it's more like 25 minutes into class. And we need that time for what we're going to do today with optimization. All right, so we'll come back to this one, if not today, on Monday. So for optimization today, I thought it'd be easiest if I just gave you what we're going to do. We are going to do the first derivative test and the second derivative test. We are going to do them with word problems today. Which actually, hopefully, will make them a little bit easier. This has not only your class examples for today, but it also, in fact, has your homework assignment for today, too. This is literally everything that is on my slides is on this sheet of paper, and it is also in Canvas, right below the slides, as a matter of fact. So, we all have it. So let's move on to our, not our second slide, but actually our third slide, where we talk about the rules for optimization. So we're on to slide 3, which begins our notes here up at the top, rules for optimization. So the rules I have are pretty straightforward and pretty simple. Pretty straightforward and pretty simple. First thing you want to do is you want to find the equation that we intend to maximize or minimize. We are trying to optimize this thing, so that means that we are going to be looking at its extremes. We are going to be looking at its values. So the fact that I've told you that we're going to be looking at extremes tells us that we are going to be doing what types of tests? First derivative test. First derivative test. Now, sometimes we might not just stop there. We might also go to the second derivative test because confirming that value might be easier at a second derivative rather than the original function we're at the first derivative. That is a case-by-case basis. That's what makes these problems a little bit more challenging, because they are real-world problems. Each one is unique. So find that equation. Get it set up. You need to reduce this equation down to a singular variable. Down to a singular variable. Because if we don't, then we're back to related rates that we talked about back in 2.6. And you guys didn't like the related rates problems where we had derivative of A, and then dA over d theta. We didn't like when we had to do multiple implicit differentiation. You guys really did not do well with those. We did well in class with them, but we did not do well with them on the test. It was the most missed test questions. The most missed test questions. So, trying a little different technique here. You need to get this down to a singular variable. Preferably the one that we are concerned about maximizing or minimizing. We will then, once we get it down to a singular variable, we're going to find the critical values by taking the derivative and essentially setting up our first derivative test. We're not going to be focusing too much on where these don't exist. We're going to be focusing more on where they are zeros because this is a real world problem. So does not exist doesn't help us in the real world. We'll verify those values as max or mins, and then of course we will need to answer our question. Which means go back and double check your parameters, your reality. Questions here. So let's move on then. Move on to the next slide, what should be 1, 2, 3 slabs 4, and our first question. You might find that some of these are somewhat familiar, at least the first couple ones, because I borrowed them from Math 2. Because you see, not only can you do them with calculus, but you can also do them with algebra. But I want to show you how you can do this with calculus. So let's start here. I have the product of two positive numbers is 20. I want us to find the minimum sum that one of the numbers and 5 times the other will make. Let's read that again, slowly, more carefully this time. I have the product of two positive numbers, makes 20. I want to find the minimum sum of one number plus 5 times the other. So let's start with some equations. That's rule number 1. Find the equation we are trying to minimize or maximize. So if you are going to follow along with my slides, you already see that probably this is already all filled in for you, but I prefer that you don't. I prefer that we do it together. How should we set up our two equations here that we're talking about? I hear two equations when I read this problem. What do they look like?
X plus y plus 20.
No, not x plus y.
X times y.
X times y is 20. So I got xy is 20. What else do we got?
X plus 5y.
And x plus 5y is what we want to minimize. Right? So this is the actual equation I am concerned about. This is what I actually want to do my derivative on. This is what I want to actually get critical values for. Yes? Okay? So that helps us clear up what's in the red box there. So the red box I start with, let x be the first number and y be the second number. That gives us x, y equal 20. And we want to find the minimum for x plus 5y. Are we all set here? Just laying out the framework of our problem. Okay. Next step is to do what? What's my rules for optimization? What's the next thing we need to do? Right up at the top of the sheet, I gave you those rules, so let's go back to those. What's the next thing? Okay, so we need to get this to one variable. What variable do you want to get it to? X or Y? It don't make a difference to me. I did it one way on the board, but I can do it a different way on this board if I need to.
X.
X. Get it down to an X. Okay? So how do I get rid of Y? If I want to get this down to just X's, what do I got to do to get rid of Y?
You have to solve for x on the or solve
Use
for
this
y on
one to help us find out. Okay, so what are we going to do here?
Divide yourself by x.
Okay, so that gives me y is equal to 20 over x. Now what?
Substitute the y in the other one.
Okay, so I got x plus 5 times 20 over x. I'm going to go ahead and write that as s for sum. Okay? Are we okay? I think we might want to reduce this a little bit. What should we rewrite this as? X plus what? 100. I'm going to go x to the negative first because what are we about to do next? I want critical value, so what do I need to do next? No, you're a little ahead of me. We got to do something before we set it equal to 0. Derivative. We got to get to the first derivative before we can do setting them equal to 0. So first derivative of our sum here. Okay, well, the derivative of x is just 1. This one here is going to become negative 100 x to the negative second. Yes? So I have 1 plus, I guess it should be 1 minus 100 over x squared. Okay, now, Maddie, what did you say? We're going to set it equal to 0. Okay, so when does this mess? Equal 0. You can either use algebra to help you finish it out, or you can use common sense. What do you guys want to do? Okay, so if I want to solve this with algebra, what should I do?
100 over x squared.
Okay, so now I've got 1 equal to 100 over x squared. Okay, now what?
Multiply by x squared.
Okay, so I got x squared equal 100.
So x equals plus minus 10.
Okay, which one of these can we actually use? Which one of these can we actually use?
Oh, positive.
It says the product of two positive numbers, so I don't care about negative 10, I only care about positive 10. Has to be positive. Now what? Now what? If you're not sure, let's go back to our rules.
Oh, yeah.
We found the critical values. Now what?
You can figure out. Verify that it's minimum.
Okay, so how are we going to do that? Use the number line, okay. Throw markers on the ground. Let's use our number line to verify. We're concerned about positive 10, so what are we going to test below it? Pardon? 9. Okay, so when I plug in 9, what do I get? Go back to this equation right here, red. What do we get? It's going to be positive or going to be negative?
Negative.
Give us a negative here. Give us a negative here. Because a fraction will come out to be bigger than 1. So when we subtract, we'll end up with a negative. What about on the other side of 10? If I put in like, I don't know, let's say 20. It'll be positive. Okay, isn't that a minimum? It has to go from decreasing to increasing, right? That's one way we can confirm this. What's the other way that we would verify that this is a minimum? Could we not go to the second derivative and test to see if it's concave up or down? So that's the other way that you could have done that. is you could have went to the next derivative. You could have went one more lower, which would have been 200 over x to the third, right? We all okay with that? And then plug in your 10. Does it spit out positive or negative? If it's positive, then we must be concave up, which would also imply a minimum, right? So there's two ways you can verify that. That's why I said, depending on the problem, depending on what we're doing, sometimes this is easy, as it was here. Sometimes it's easier just to go to the next derivative and plug your numbers directly in to see if we are concave up or down, to verify max versus mean. Okay? All right, so what's the answer? What's the answer? That's the last thing, is answer the question, right? Min at what?
Well, 10 is just x, so you have to solve the line.
Okay, so 10, comma, 2, okay, with a sum of
20.
remember what we're trying to minimize, this right here, right? X is 10, y is 2, that makes these total minimum sum 20. That's the smallest sum that we can have. So let's run back through our work here with our boxes. So we start with the red box. Gave us our derivative, as we have here. Then in the blue box, we did that substitution, and that's what I have in green. Then we found the zeros of this. We found x to be 10. Then we have to test this. So we use the number line. That's what I did up there, because I thought the number line was easiest for this particular problem. Once again, could have did a second derivative and test the concavity. That would work too. We talked about that on 3.4 on Thursday last week, which was almost a while ago now. We get our values, we get our final answer. On to the next problem then. On to the next slide. Example 2. Area maximization. This is also a callback to a Math 2 problem. What do we have here? What do we got going on here? Read it over. Read it a couple times if we need to. I saved us an hour to do 5 problems. I am not going to just grab the bull by the horns here and start leading you through them. I won't do that for your test. Not going to do that for your quiz. You need to be able to figure out how to approach these on your own. You got to critical think. You got to problem solve. Jake, what you got for me?
2xy equals 500.
2xy equals 500. Where are we getting this from?
You have a rectangular pen, but you don't have one of the sides. So you take one of the sides away and set it equal to 500.
I think there's a better way to write this, Jake.
Okay.
I get what you're saying. Let's draw a picture, Jake, to help everybody visualize what you're saying, okay? So we got our river on this side. Okay, that's going to act as one of our boundaries to our rectangle, right? So that gives us 1, 2, 3 sides that we need. Now Jake is seeing this one here as x and this one here as x because that's where we're getting our 2 x's from, yes? So he's calling this last side here y. I think there's a better way to refer to this last side than calling it y. This is the same trick I did in Math 2 when we did this question. Same trick we did in Math 2. I'm about to do it with them on Monday. What should we call it? How about you guys in chat? What do you guys got? Let's build off of Jake's thoughts. Jake, I like that you said we had the 2 x's. I like that you said about the 500, but the 500 wasn't in the right spot. You see, you had me set that up as though that was the area. 500 is not the area. 500 is the perimeter.
So, okay, so is it another x?
So first, let's fix Jake's equation. Jake's equation should have been 2x plus y equal to 500. But I don't like y here. I want to find something else to put in its place. Let's rewrite this so that way instead of calling this side y, we can call it a form of x, right? Because ultimately, the equation we want to maximize here is area. The area, as Jake's defining it, would be simply x times y, right? So Jake's on track with his thought process, but what I'm trying to drive you at is the next step. The next step is to reduce this down to a singular variable, yes? Okay, so how are we going to do that? Jake's given all the blueprints that we need here.
Y equals 500 over 2x.
500 over 2x? You're still looking at it from your wrong equation earlier.
I got you. It's a 2 over negative 2x plus 500.
If you got 500 feet to make up your fence, and I'm taking away 2x's worth of it, then this last side would be 500, take away whatever those 2x's was. Those x's are 10, we're going to take away 20. Those x's are 6, we're going to take away 12. That's how I would refer to this, and that's how I draw my picture from the very start. And make no mistake, guys and gals, this is 100% a Math 2 question. I have done this with you all once before. We did it with vertex. We did maximums and minimums. This is a quadratic function. When we get to this part right here, we're going to substitute this in for our y instead, making our area function x times 500 minus 2x, or negative 2x squared plus 500x, which is what we did in Math 2. And then I would tell you, find me the vertex of this, which is the maximum or minimum, right? But now we're not doing that. Now we're going to go ahead and we're going to optimize it. We have to get one step farther. So this is no more or less difficult than what you've done in the past. I'm going to show you a different way to do it. So let's pick up with where we're at. So what we have established here on this slide, for example 2, is we've done what's in red to get our area formula all flushed out here. Get our area formula all flushed out here. What are we going to do next?
find the first derivative.
We're gonna do the first derivative, okay? So what's the first derivative of the area here?
Negative 4x plus 500.
Okay, and what are we gonna do with this?
That equals 0.
Okay? Now what?
Solve, get x equals 1.5.
Are we all okay with what we've done so far? Okay, we need to test it. How do you want to test it? First derivative, second derivative. This is what we've done so far. Bianca's taken us through what we got in the next box here in blue. She's gotten us or not blue, green. Just colorblind apparently. So now we need to verify. How do you want to verify it? There's an easy way and an even easier way. What do you guys want to do?
Second derivative.
Okay, Bianca says second derivative. Bianca's doing the easiest way possible. Second derivative here, what would a double prime be here? What's the second derivative? Negative 4. So it's always concave down, which means that it's a max. The CCD, only max. We talked about this at the end of our 3.4 slides. If we are concave down, then any critical values in that window must be maximums. If we are concave up, then any critical values in that window must be minimums. This is concave down on the entire interval from negative infinite to infinite. So we can only have maximums here. So we have verified, so now what do we got to do? Somebody other than Bianca and Jake. What do the other three of you got to say? Yep. The next part is after verify is answer the question, right? Okay, so let's answer the question. Where do you want to plug it in? Do I need y here? Do I actually need the other value? No, I could get it if I need it. But what I really want here is I want the maximum area, right? I got an equation for x with area. I got x, right? So why go all the way back? Why not just pick it up from right here? Area, negative 2, 125 squared, 500 times 125. What are we looking at? $31,250. It's a good thing you said that, Bianca. I was about to ask, what are we missing? So, on the board, on the slides, I verified it through the same test. The first derivative, I did the number line. So I picked 124, I put it in, I got a positive number. I picked 126, put it in, got a negative number. So positive and negative indicates increasing to decreasing, which indicates concave down, which means max. And then we plug it in. If you wanted to get y, you could. Y should be 250. Questions here? Concerns here? That took longer than it should have. Not even the hard ones yet. First three are all from Math 2. We haven't even gotten to the actual problems like number 4, number 5. Speaking of, let's move on to number 3, our open box problem. Our third example here, our open box problem. Now, I'm going to go ahead and give you a little picture here to get started with it to better understand it. You guys take a look at it, read through, and let me know what you think. Looking at example number 3, and this should probably be, I believe it's slide 6 for us. Double check the slide number. We're on slide 6 now, example number 3. How's everybody at home doing? Are we doing okay with these? Yes, no, maybe. Thank you, Dawson, for answering. At the very least, I hope you can all understand why I did not want to do this lesson via a pre-recorded video. Thank you, Michaela. Give us 2 or 3 more minutes to work on this one, see how far we can get along. I'm going to go ahead and throw this out there as well. I wasn't shocked or surprised by how our last quiz went. I probably won't be shocked or surprised by how this quiz goes. We don't do a good enough job asking questions. We don't do a good enough job with our work. And it's starting to show. As these problems get longer and more difficult and more involved, we're struggling. That last quiz wasn't real pretty, was it? Maybe for a few of you it went just fine. But for a number of you, I'm sure that was a pretty rough grade. It is not going to get better if we don't ask more questions, if we don't get more involved. And that's not just you guys here, that's you guys at home on live stream too. And it's when you guys go home on live stream. We need to be more involved at all aspects of it. I'll also say that not a single one of you from AP Calculus showed up this Wednesday. So we are changing the way we are doing office hours because I am tired of sitting around waiting for an hour plus for anyone to come strolling by. So my new strategy here is what I'm going to do is I'm going to make the first half hour by appointment. You want to come in individual time, you come on in on individual time by appointment only. That way, if you're struggling and you don't want it to be known to everybody and their mother that you're struggling, you can set up an appointment with me. Then the second half hour, we'll do just as we are doing. You can drop by. At least that way, I'm not wasting a full hour of my time sitting there for no one to show up. At least this way, I'll only waste a half hour at a time. Let's talk about my problem here. Where are we going to get started? What do we need? An equation? What type of equation? A volume equation, okay? So, now we're going to set it up.
The volume is essentially area times height.
Okay.
So you know your area, the total area is 24.
Okay.
And you're taking squares out of the corners.
Yeah.
So if you call the length of the sides of the small squares x,
Okay.
you're taking out 4x squared from the total area,
Okay.
right?
Okay.
So I got v equals 24 minus 4x squared in parentheses, and then times the height, which is just going to be x.
What do we think? I don't know how I feel about it.
Neither.
Okay. Rather than tell you the answer, here. That's what I got. That's what I've got. Explain it back to me. That's my equation in the red box. Explain how I got that. Jake?
The minus the 24, you have 24 on one side, and then you have 2 x's because of each corner.
Yep.
So you just got to take away the 2x from the side.
Yep.
Okay, wait, I think I'm misreading it. Is the area 24 or
Nope.
are the side lengths 24?
The side length is
It says-
24.
24 inches squared, so I thought that meant the area was 24. That's why I was confused.
I can understand why you'd have that confusion. I'll change the wording on that one for next time. Bad wording there. I get that. Everybody okay with our equation? Not saying that you were wrong. I meant to say that that it itself is a square with sides of 4. Mr. Kaufman is not great at English. Why use many word when few word do? So, nonetheless, now we have our equation. Volume equal to 4x to the third minus our 96 x squared and plus 576 x. So how I got this, of course, it's going to be x tall, right? When we take this away, we fold it up, it'll be x tall. That'll be the sides coming up. And then each side length was 24. I took away 2 x's from it, so that's what I have in my parentheses is 24 minus 2x. I highly recommend you FOIL those two together and then distribute an x through rather than trying to do it any other way. But by all means, if you want to make it more difficult, you make it as difficult as you want it to be. Okay, gang, what are we going to do now? First derivative. What is it?
12x squared minus 192. Wait. Yeah, 192x plus 576.
Are we all okay with our second derivative? What are we going to do with it?
30%.
I bet that we can take a GCF out of this. What do you think? I bet we can take a GCF out of this. What do you guys think? What is it? 12. Okay, what does that give us, team? Square minus what? 16x and 48. Okay. Now what? Okay. Which means what? Are we going to factor? We're going to quadratic formula. What are we going to do with this inside here? Does it factor? Does it give us a nice number when we factor it out? Do we have to do the quadratic formula? What's it going to do? Okay, what's it factor into then?
X minus 12 and x minus 4.
Good? I think so. Twelve and 4 make 48. Negative, negative will make negative 16. I think it's all good. Okay, what does that give me for my side lengths?
12 and 4. 12
and 4 then. Those are my critical numbers. Yep. So now I have two of them, so we do have to test them. Right? How do you guys want to test them? Do you guys want to do the second derivative, or you guys want to go back to the number line? It's your choice. Doesn't make much of a difference to me. I know what I did on the board. I know what I did on the screen there with my slides. Let's catch up to them. So, picked up what I have in the green box, which is where we just left off. So now we need to verify. We got our critical numbers. Now we need to verify. How do you want to verify? We can either use second derivative test and see if we're concave up or concave down. Or we could also try to do our number line. What are we thinking? If Bianca says second derivative, before we go on, why do I have x can't be equal to 12? What's the problem with that?
Because it would take away the principal.
It takes away the entire box. And then there's no box left. If I put in the size that I'm taking away, the little corners I'm cutting out, if I cut out 12 on that side, 12 on this side, then there is no box left to fold up. So it can't be 12, so we're really only considering 4 here as our critical value. Bianca, you said you wanted to do the second derivative, so okay, let's do the second derivative of the volume. That's going to be 24x minus 192. Okay? When I plug in 4, what do I get? The positive or negative?
Negative.
Negative, okay, so that means that we are concave down. Yes? Which means max. Now what?
Plug it back in.
Plug it back in, okay? Grind it out. What do we get?
1,024 cubic inches.
1,024? It should go without saying, but I'm gonna say it anyway. If you don't put your units, I'm taking off the point. Questions? So Bianca chose second derivative test. Seems like that's the preferred method for Miss Rushing here, as she's and Jake seem to be the only two really providing much feedback. The rest of you guys are pretty quiet here. Ladies. Judgment being cast upon you. On the slides, I went and did the interval because I actually think the interval test is easier on this one. Because I'm just going to put in 3, that's going to be negative, that's going to be negative, 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 make it positive. And then if I put in 5, that's negative, that's positive, that makes negative. So I'm going from positive to negative. That implies max. Plus to minus implies max. But to each your own. I mean, it's not like that this is very difficult either. It's not. But you do have your choice there how you want to verify. And this one works pretty easily to do the second derivative just as easily as it does the first. I will tell you that is not going to be the case on the next couple ones because we are leaving Math 2 after this. We plug it in, we get our answer, 1024 cubic inches. Are we all set here? So far today, we have done 3 example problems. And yeah, we've been doing this for just about an hour now. So we're only averaging 20 minutes a problem. And these are the easy ones. Okay, let's move on to a more difficult one. So, slide 7, example number 4. All my work magically popped up, unfortunately. So we're going to skip over that one so I can fix it. Let's go on to slide 5. Or example 5, which would be slide 8. Yeah, let's go on to this one. And I'll go fix the motion on that one because it's out of order, apparently. So example 5, we'll move back to example 4. Slide number 8. The distance minimization. Okay, got it fixed. So we'll move back to the example 4 in a second. Hopefully we get time to do them all. Definitely not going to get a chance to do the additional problem that I have for us, the checkpoint problem. I will also say that it's painfully obvious which ones of you are kind of relying on which other ones to help you out when you get stuck, because you all tend to make the same mistakes. I can tell if 2 or 3 people are talking with one another because they'll make the same mistake on their quiz and make the same mistake on the test, or make a similar one, I should say. I haven't had much issues other than what we addressed before about cheating, about helping each other too much, but I can still tell who all likes to work together. It's interesting to see the similarities in your work. But I think we've done a little bit better job of that. Did I do something good? What do we think? What was said? Distance, right? So perhaps the distance formula may help. The Oracle knows all. Good work. Good start. Yeah.
No,
Nothing. We gotta do something.
I mean, I did like Desmond, guess and check.
No, we ain't gonna Desmos and guess and check.
But the only option,
No, it's not. What's the very first word, Jake?
fine,
No.
distance.
Yep. Guess what formula you should probably go with? I'm gonna eat something at you. How are we doing at home? All right, Mr. Coffman's tired of waiting. Plus, I got a whole other problem to do, and I got like 10 minutes to get them both done. Okay, I want minimum distance. So what am I trying to minimize here? The distance formula, yes? Okay, so let's get started with that. Let's get started with this, okay? So I have y equals square root x, which would mean x is equal to y squared. Okay? That's where we're going to begin. Now, we're going to go to our distance formula. Standard distance formula, x2 minus x1 quantity squared, plus y2 minus y1 quantity squared, right? So, this is how I get rid of that. This is how I get rid of that. What did I do? Between my distance formula, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. What did I do? How did I get from there to the green box? What do we have that we can put in? What do we have that we can put in?
0, 3.
0 and 3, okay. 0 and 3 are going to be what?
X2 and X.
I think they should be x1 and y1, don't you? Okay. So that leaves me x minus 0 squared plus y minus 3 squared. Okay? Now we need to get this down to a single variable, right? Okay, this is a situation where it is best not to get rid of y. It is best not to get rid of y, because y is equal to the square root of x. If I put root x in here, it's not going to go very well because I got roots inside of roots then. That makes this way more complicated than what it will need to be. The easier way is to stay away from compounding your roots together. That's why I have this here, y squared is equal to x. So that's the substitution I'm going to pull here, is that this becomes y squared quantity squared plus y minus 3 quantity squared all under my root. And for those of you wondering, can't you just cancel those powers? No, that's not how square roots work. This becomes y to the 4th plus y squared plus 6y minus 9. Oh, I got some signs backwards. Let's try that again. Minus 6y plus 9. All in my root here. Questions? Okay? Same question as always. What now? What now? Derivatives. Okay? I think this one works best with a little bit of substitution. I think this one works best with a little substitution here. So that's what I'm going to do, is I'm going to use sub out, or I use g here. But I'm going to set all of this equal to g. Y to the 4th plus y squared minus 6y plus 9 gives me g derivative as 4y cubed plus 2y minus 6. So that way this becomes root g for my distance, which will become g to the 1/2, which is 1/2 times g's derivative, right? Are we all okay? So, finish it out. Find your critical values. More importantly, I guess you don't even really need to go this far, to be honest. You don't even really need to go this far. If you really want to make it shortened up, we're going to end up with some type of root here, right? When we take the square root of, if I go back to my use substitution here, right? We've done this a number of times. This is going to be 1 over 2 and then the square root in the bottom, right? Okay, so we're not concerned about where things don't exist. So we're not going to be worried about when the root and the denominator equals 0. What we're going to be focused on is what's going to happen up on the top with the secondary part of our chain rule, where this, which will be on the numerator, is going to be equal to 0, right? So that's one way you can, of course, speed this up, is you can take this, set it equal to 0, and solve it down. Gives you 1, which, of course, you can plug back in and get 1, 1. Questions? Concerns? Okay. Let's go back to slide 7. With my volume and surface area question. I like this one. Jake, you got your Chromebook open there. What's the time?
It's 11:31.
11:31. Okay, Mr. Kaufman going to have to lead us through this one. I don't got time for you guys to sit here and twiddle your thumbs and wait for me to do it. I'll just do it now. So, volume and surface area. So I have a cylindrical can. Must be made to hold 1 liter of oil. I want to find the dimensions that minimize the cost of the metal that's used. Okay, so the area, the question at hand here is, what is the minimum surface area? That is the question that I want to talk about. I want to talk about the correct dimensions here. Correct dimensions. So we don't need the volume because we're not making this solid. That's why we're not going to go with a minimum or maximum on the volume. That's not what we want here. This is not a solid cylinder. It's hollow. So we are only concerned about the surface area. It's like a can of Coke. So I want to know how much aluminum, how much metal do I have to wrap around the cylinder, quote unquote, to make the volume work. So I'm going to start with what they gave me here, which is how much I need this to hold in the first place. So starting with that, I have the volume is equal to pi r squared h. That's the standard volume formula for a cylinder. I need this to match 1 liter's worth. 1 liter's worth. So I solve it down. What I'm going to do here is I'm going to rearrange this for R. The reason being is because the surface area formula that I'm interested in, I have a typo there, by the way, if that's what you're looking at. It should be 1,000 there, not 100. Surface area formula for a cylinder is 2 pi r squared plus 2 pi r h. It's going to be way easier to eliminate that singular h at the end than it is to get rid of both of the r's. Don't you agree? So let's take this formula in brown and let's rearrange it so that way we can substitute it. So what I did is I went straight to 1,000 pi r squared h, and then I just swapped the h and 1,000. So this is going to become 1,000 divided by pi r squared. Now this is going to go in for this h right here. So my surface area formula is turning out to be 2 pi r squared, that's not changed, plus 2 pi r times 1,000 over pi r squared. Are we okay with this so far? Okay, now there's a little simplifying we can do here with this formula. I can drop these pi's, I can drop that r, and this is going to give me 2,000 over r for my second term, and I still have 2 pi r squared for my first term. All of this is my simplified surface area formula. Are you okay with the work that I have done? Good, 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 good. Okay. So that's what I've done in my red block, and in my blue block is just done a little bit of simplifying down. Simplifying down. Now, you probably are going to want to rewrite this so that way it's r to the negative first, because we are about to do what we've done all class period, and we're going to take the derivative. So I'm going to treat this as a constant. This is going to become 4 pi r, and this is going to become negative 2,000 r to the negative second, or over r squared. Make no mistake, guys and gals, this is a real question. I know this for a fact because this is what my sister used to do before she moved into her new role as a data analytic. Is she used to do stuff like this for Bayer. That's who she worked for. Finding out what is the best measurements to make a pill container, because those things matter when you're making millions of them at a time. And saving even just a fraction of a millimeter cuts cost by thousands of dollars, which means somebody might get to keep their job. Or if you do that wrong, it means increasing cost by thousands of dollars, meaning somebody might lose their job somewhere along the line. This is work that some of you actually might end up doing as part of your career. Make no mistake. Okay? We have our formula. We need to get the zeros of our formula. Set the whole thing equal to 0. I think the easiest thing to do is bring this over and make this 2,000 r squared equal to 4 pi r. I think the easiest thing to do is bring the r out of the denominator. 2,000 4 pi r cubed. Divide the 4 over. That's going to give us 500 pi r cubed. You can divide by pi and take the cube roots. You should get r roughly, it's not going to be perfect here because this is a real world problem. You're going to get r to roughly be 5.419. If you wanted to call it 5.42, I would take that. Now let's be clear here. What measurement would this be? I went from liter to milliliters. How does that translate over to centimeters? Do you know?
Milliliter is
1 milliliter is equal to 1 cubic centimeter. So this is centimeters. That's the great thing about metric, is it all works so nicely. That's why it was designed and made up that way as opposed to the units we use in this country. Now that I have R, I can go back and find H. Of course, we should test this, but I'm out of time. You can test it on your own. I think this is absolutely one that you don't want to go to the next derivative down. I really don't think you want to do that. I would just test right above, right below. I think that would be much, much easier. Plug in 5 and plug in 6 back into your first derivative. I think doing the interval line here is way easier. When you plug it back in, you should get an H of 10.84 centimeters. Questions? Okay, you got those 5 problems at the 5, 6 problems down at the bottom there. You don't have to do the checkpoint problem, but you do need to do the 5 at the bottom. Those are your homework. Finish the sheet. Then your homework, finish your sheet. We will pick up linearization on Monday, and then we will be done. I don't know if we're going to do a third quiz. I thought about it. I'm still thinking about it. I haven't fully decided. If I do, it won't come up till Monday. So you don't need to worry about it. Because if I do, it'll be this in linearization. Guys on the live stream, I'll see you later. Hopefully I'll have a good weekend. Let's come in Monday ready to go with all of our homework completed.